Right. Good evening. Welcome back to a video. Yeah, it's been a while. For test three, we've been getting into some pretty rad stuff, and I'm just gonna say it's quick. It's not gonna slow down, so we should go ahead and get into nomenclature. Now, toward the end of the video, I'll be getting into chapter 16 nomenclature as well. So that deals with aldehydes and ketones as well. Something we have not quite learned just yet, but we will probably get to. So I'm just going to put it all in one video. And you guys will kind of get a pattern because aldehydes and ketones are definitely easier compared to your esters and your amides. So we'll see it. I'm going to go and share my screen. Yeah. All right. You guys should see my screen. This will see some analytical chem. Okay. Let me pull this up. Great. Okay. So the first thing I want to note is you guys from OChem 1 have gone over a priority chart. And if you remember, you have your alcohols having the highest priority, then your amines, then your like alkenes, alkynes, alkanes, and then all the other branch status groups. So that your alkyl halides, your I said epoxide, your ethoxy, methoxy, your ether groups, right? Well, we expanded on that a little bit with benzene rings that kind of follow a similar pattern, but now that we're back to like mate and carbon chains, well, what's the new priority? Well, the general gist is that above everything else, because everything you just learned is like all of your branch status. So that's like your BR, CL, alkyl groups like ET for ethane or ethyl groups. Those are branch status groups. They don't change. Now the bottom of the barrel are going to be like your alkenes. That's the wrong thing. Alkenes and alkynes. Here. Your alkynes. Okay. And then you have your amines and your alcohols. Well, the thing is, it kind of changes a little bit because there's a lot more. So everything that I just mentioned is stuff that you remember from OChem 1. Now we have a whole bunch of more new terms that we have to look at. So remember the general pattern. Whatever parent chain you have, that parent functional group, the highest priority becomes a suffix. So if you have an amino group, an NH2, and an alcohol group, you put them in the same compound, the alcohol group takes priority because it's the highest priority. So that becomes a suffix. And your amine group now becomes a prefix. Everything else other than your parent top chain or your top priority group becomes branch status, if you remember. Okay. So if you have an amine and an alcohol, well, it's going to be like 4-amino-butan-1-ol. Because the alcohol gets priority. Well, for the new list, the easiest thing is going to be carboxylic acids are the top. All right, they have the highest priority, no matter what. So if you see carboxylic acid, you know there's no other functional group that takes priority over it. It has to be the top, right? And anything else are going to be carboxylic acid derivatives. So on top of it, you're going to have like your esters, amides, methanoyl, well, acyl halides. All right. And then you have all of your weird ones. So like your nitriles, your aldehydes, ketones. You might be thinking, well, that's a whole bunch. Is there a list? Well, yeah. So in my TA notes, I actually have a cohesive list of all of the parent chain, parent group ranking, and all of their respective prefixes and suffixes. Okay. Now I want to make note. Now that we've changed gears over here, look, we have our carboxylic acid at the very top. And let's ignore sulfonic acid right now because you're not going to be really naming that. Your esters, acyl halides, amides, they're all right afterwards. So carboxylic acids and their derivatives are going to be the highest priority. Same thing with the nitriles. Their nitriles can be carboxylic acids. And I'm missing a. That's embarrassing. And then right after our carboxylic acid group right here, we have our aldehydes, ketones, and then the rest of the stuff we're working with, like alcohols. We've seen amine, we've seen, and all of the other stuff that we've already seen from last semester, right? Now take a look at the suffixes and prefixes. You can see that in my notes, I've highlighted specific ones. Now, these highlights I've made back when I was taking OChem, and these are the ones that you definitely have to know. And make sure you note, well, hey, look, all these carboxylic acid derivatives, I highlighted the suffixes because that's the main thing. Because remember, suffixes mean that they're the parent group. So if you have a ester, you know that your suffix is going to be some kind of O8, so like benzoate, okay? You're rarely going to see them as a branch status group, like carbomoyl. You're not going to really see that, right? And that makes sense because the only way you would have this as a prefix is if you have something a lot higher be the suffix. So if you have a carboxylic acid, and on top of that chain, you have an ester and a nitrile. So if your carboxylic acid takes priority, right, it becomes your suffix oic acid, and you use oxycarbonyl and cyano prefixes to name the branches. And that's a little bit of a bitch. We don't really like that. So we usually like to stick with one of these groups. And you'll see later on about the practice, we kind of deal with that, okay? Yeah, so this should be available for you guys. So let's go and start naming benzoic acid, not benzoic acid, carboxylic acids. So carboxylic acids are really, really easy because like aldehydes, and you will see aldehydes like this, they're always going to be on the terminal ends. So that means they're rarely in the middle. They're usually going to be on the very end. So if you know that, okay, well, if it's going to be on the very end and it's the highest priority, well, that's our first carbon. And that's always going to be the case. So if we look at this chain, we have 1, 2, 3, 4, 5, 6, right? And which one do I start with, left or right? Well, we know for a fact this is the only one with a functional group, and we know it's a carboxylic acid. So it's the first one. So this is our first carbon. 2, 3, 4, 5, 6. We don't have any other branches. It's just our basic hexanoic acid. And if you know your common names, this is caprylic acid. And you should know the you will know the common names because it's going to be on your test. Now, what if it's written like this? Dr. Berg, knowing Dr. Berg, he might as well write it like this sometimes because OChem hates you, right? And it feels that way. I get it. Well, a lot of you are tempted to just count 1, 2, 3, 4, 5, 6, 7. And this would be like carboxylic acid and then on the third carbon. No, that does not work. It must be your first carbon, right? Because that has to be part of your parent chain. Now, if this is going to be our second carbon, which way do we go? Well, same rules apply. We want to have the longest carbon chain. 3, 4, 5, 6. And this is just an ethyl group because if I were to rewrite it per se, 6. This is another way to look at it. 2, 5, 6. Right? This is an ethyl group hanging off that second carbon. So if we know that that's what it's going to be, it's going to be 2-ethyl hexanoic acid. And note, there is a space, right? This is one of the weird ones where there's a space. And the ones where there's a space is going to be your acyl halides. And there might be space in your esters when you have like ethyl benzoate, stuff like that. We'll get into it. But what you note is whatever your parent group is, like hexane, you drop the E and you put oic acid. Stuff we've already dealt with, right? Like hexanol, you drop the E, you put the OL. Now the note here, should you put in number 1? Well, I'm just going to say no because it's implied because your carboxylic acid is pretty much going to be that first carbon. They're thinking, can I still put it? Because I really want to. Well, it's a redundant one. You can. Why wouldn't I just leave it? Don't worry about it. Don't worry. Have you ever seen Dr. Berg do that? No, I'm not going to do it. I wouldn't. So now let's kick it up a notch. Let's go over here. So I see in amine group, you might be tempted. Well, hey, I got to start 1, 2, 3, 4, 5, 6. Because, hey, I know that amines are going to be priority groups. Well, compared to your other priority groups, carboxylic acids way outshine your amine group. So it has to be your priority. Carbon 1, 2, 3, 4, 5, 6. So your amine is on that 4th carbon. Now, what the heck do we do with this? Well, that is a branch. And remember, if you have a branch on an amine group, because amine groups can be substituted, you denote it with N. to be N-methyl, because that's what's on it. Not a dimethyl or trimethyl, just one methyl group. N-methyl 4-amino hexanoic acid. All right. I know, okay, our our carboxylic acid, the priority group, everything else are branch status groups. So our methyl group, branch, amino group, branch. Okay. Now, let's take another look. What if we have a dioic acid? That's where it gets a little weird. Is 1, 2, 3, 4. This is going to be butane dioic acid. You do not drop this E. You retain it. Kind of like how you have like cyclohexane 1,3-diol. Same kind of rules. We do not drop that E. So the moment you have a consonant in the next, like the D in the dioic acid, that means you do not drop the E. You keep the vowel there. Okay. Now technically, if it would be butane 1,4-dioic acid, be the more correct term. Now, for the anhydrides, this is really easy because whatever carboxylic acid you have, you just replace the word with anhydride. All right. And the anhydrides that Dr. Berg gives you will most likely be symmetrical because that's how we make it in the lab. Because you just take 2 carboxylic acids, you just heat it up and they will smush together. So if I see, okay, I have an anhydride group, anhydride, I have carbonyl, oxygen combined with 2 carboxylic acids. If I were to split this in half, what's that carboxylic acid component? That looks like ethanoic acid or acetic acid. So I would thus infer, hey, if it's going to be 2 ethanoic acids, ethanoic anhydride, and you're thinking, well, there's 4 carbons total. Well, yeah, there is 4 carbons total, but each of the acid components are ethanoic acids. So it's kind of implied that you have 2 components because that's how we deal with it. All right. Now for this one, I did not fact check it. I think this one's Give me 1 second. I'm gonna fact check it. I've made a big mistake. I took this from my notes, and that's just succinic anhydride. Because succinic acid, if you remember, this is the anhydride version. However, that's the common name. The IUPAC name uses ketone naming, and this is not the part we're looking at. So we're going to ignore this. I apologize. So ignore this for now. So we finished talking about anhydrides, right? And now we're looking at the other carboxylic acid derivatives. The next easy one is going to be the acyl halides. So the acyl halides, well, it follows kind of similar rule. So we know, okay, let's go ahead and name this carboxylic acid. 1, 2, 3, 4, 5. Pentan, drop the E, oic acid. Okay. Now, if it's 1, 2, 3, 4, 5, a pentane again, but now you have an acyl chloride where you have a halogen instead of the OH, it's now an acyl chloride, pentan, noyl chloride. You take the oic acid, replace it with oil, like OYL, and then you put whatever halide anion name is in there. So another one is bromide. So if 1, 2, 3, 4, this is going to be butane, drop the E. And it would be butanoic acid, but it's going to be butanoyl bromide. Now, you won't use bromide because we like chlorine for the chemistry because acyl chlorides are amazing. So I'm just saying this right now. You won't really see that, but I'm just trying to make it clear. The bromide, the chloride, it matches with whatever group you have. So let's try to combine a little bit. So if we know, okay, hey, we have a priority group in acyl chloride. So between an ethyl group, which is the branch status, OH group, which is a priority group, acyl chlorides take priority. So if I know that that takes priority, 1, 2, 3, 4, 5, 6. So I have a 3-ethyl and then 3-hydroxy. Now, if I'm going to name it IUPAC wise, we have to follow alphabetical, not for naming, but as we write it out. 3-ethyl, 3-hydroxy, because H goes before E. E comes before H in the alphabet. Hydroxy, 1, 2, 3, 4, 5, 6. Hexane. No, it would be oic acid, hexanoic acid. Remember, it's a chloride. Hexanoyl chloride. Okay. Now let's look down here. So if you see a double bond, remember, something should be ringing in your head. All right. If I see a double bond, I should be thinking E and Z because that's part of the name, right? If you see a double bond, write E or Z because stereochemistry matters. But for this one, Z or E, we don't put that there because look, I threw a little curveball at you guys. Those are two of the same chain. If you have identical chains on the same ridge head carbon, it's not a stereocenter. Excuse me. You could physically pretend, cut this in half, flip it around, it's the same deal. So we're going to ignore stereochemistry for now. But if it's on your problem set, make sure you pay attention. You have to write E or Z. So outside of this functional group, I only have an acyl chloride. So if I know that that's our functional group, well, it's our highest priority. I don't have any other let me start counting real quick. 1, 2, 3, 4, 5. The only other branch I have is going to be this ethyl group. So if I know, or hey, it's on the 3rd carbon, it's going to be 3-ethyl. The parent chain is going to be on the pentane. Pen. Now, you would be pentanoyl chloride, but remember, there's an alkene, and the alkene's on the 2nd carbon. Pen, 2, ene. Even though you would have the E, remember, you drop the E. Oil, chloride. The same exact rules you guys remember from semester 1. If you don't remember the rules from semester 1, well, you have the notes, so review them. All right, now let's go look over here. So you have a cyclohexanone. Okay, now you might think, what the heck did I just say? What's an one? Well, it's a ketone, and I'm going to give a little bit of a foreshadow in this example. The main thing I want to note is this group right here, because you might be thinking, well, hey, if I have a cyclic structure, this would look like a chloride, but no, this is a little bit of a curveball. This is just a normal ketone where, okay, out of 3 functional groups, you have chlorine, carbonyl, and alkene. Carbonyls take priority. So look right back up here. Ketones and aldehydes take priority over alkenes or halides. So I'll start counting here. 1, 2, 3, 4, 5, 6. Because alkenes do take priority. It'd be 6 chloro, cyclo, X, 2, ene. Now it would be ene, but you have a ketone, 1 one. That's a little bit of a foreshadow I want to show you guys because look, the suffix for ketones are going to be right here. One, like ketone. Then aldehydes are going to be Al, as in aldehyde. So we have a butanal, butan, aldehyde, butanal. That's what it would be. Or ketone, you would have, and that's acetone. Acetone is actually propan 2-one. You know? Yeah. We'll get back to that. And this is a little bit of a sneak peek I want to throw at you guys. The next thing is nitriles. So nitriles follow a little bit of a different rule than our carboxylic acids because they have to be what am I trying to say? Instead of doing that, let me just show you. You remember back here, I wrote the carboxylic acid in a weird way where it's a little bit off to the side, and I wrote out the C, right? You see the C clearly right here, and I want to emphasize I counted that 1, 2, 3, 4, 5, 6. I did not start counting here. that's because this is still a carbon. Even though that's a functional group, there's a carbon in the functional group, so that has to be the first carbon. The carbonyl carbon is usually going to be the first carbon count. That's a general trend that I will probably show you guys when we get to esters and amides. So normally, if you see this functional group, you might be inclined to think, okay, well, if this is the functional group, let's look at this first corner and count that as 1, 2, 3. You can't do that. This first carbon has to be part of the nitrile. So even though it looks like this, right? Even though it looks like that, this carbonyl nitrile is still your first carbon. So it's butane. Nope, not that one. You just take the parent chain and then you put nitrile at the end. You do not drop the E. Nitriles are a little weird because you just slap it on. Kind of like benzene, or not benzene nitrile, benzene sulfonic acid, right? That's one of the weird names you have to memorize for test 1. You didn't drop the E. Well, the same kind of goes for here, butane nitrile, right? You don't drop the E, it's just butane nitrile, the carbon chain, and then the nitrile is just there. So let me throw it out here real quick. You might be inclined, okay, hey, functional group. Let's start counting 1, 2, 3, 4, 5. No, you have to start with the carbon. So this would actually be 1, 2, 3, 4, 5 with a methyl group sticking out. So this would be 2 methyl, parent chain, pentane, keep the E, and slap a nitrile. As you know, that first carbon is going to be the nitrile. All right, if your nitrile is going to be, or if your nitrile group is your highest priority, that carbon in the nitrile is going to be your first carbon. So this one's a little bit easier. 1, 2, 3, 4, 5, 6, right? The geminal dibromo, and that first carbon in the nitrile is my first, or well, is the priority carbon. So it's going to be 3, 3, dibromo, hexane, nitrile. All right, that should make sense. Now, nitriles could be branch status groups. What if you have a nitrile in a carboxylic acid group? Well, we'll get to there. But nitrile, he likes to throw at you guys as a branch status group. So the prefix would just be cyano. So if you had like a benzoic acid, but you had a 3-cyanobenzoic acid, well, that's it. The nitrile becomes a branch status group and just cyano. But getting ahead of myself. We'll get there. Now here comes the weird part, esters and amides. So amides, or it kind of follows the conventional naming we come back to, but esters are a little bit weird because you have an ester group right here where the C terminus right here and the O terminus are named differently. So whatever's attached to the C terminus is your parent chain. And whatever's attached here to the O terminus is just a supplementary or accessory chain. So if I know, hey, what is the longest carbon chain in my main group? Well, I have 1, 2, 3, 4. Right? That carbonyl carbon, remember, has to be part of that main chain. It is carbon number 1. So if I know, hey, this is going to be my parent chain, I have an accessory chain right here, and I have a branch group over here. Okay, well, let's go ahead and write it out. What we do is there's going to be a little space. Ethyl. Right, this is derived from here. 2 methyl, just branch status, and butanoate. All right, so let's break this down. So let me write it in black. Ethyl to methyl butanoate. Okay. So O8, that is your suffix for esters. O8, kind of like the derived O8 suffixes for carboxylates, which you'll learn what it is if you don't know what it is. All right, O8, butanoate. O8 is the prefix. Butan is going to be the parent chain of here. And your accessory is always going to be a separate word. Right? It's going to be a separate word at the very beginning. And it follows the rules as a branch of a branch. So if you have, like, let's say, C-O, right? This would be a 2, no, not 2. No, not butyl group. I'll show you an example later. There's a lot of info to throw around. But yeah. And then whatever's a branch on that main chain, you treat as any branches over here. Pretend that there's branches here. I didn't just circle something in the corner. But pretend there are branches. So whatever branches exist there, you just put in front of the main chain. Right? The main chain is always going to be on the right side, while the accessory chains are going to be, right here in the beginning. So without me just rambling on, let's actually get into some examples because I think that's the best way for you guys to get this. Okay. So if I know, hey, let's look. So if I identify my carbonyl carbon, okay, where's that main chain? Well, the main chain is going to be right here. Let me erase this. Okay, not part of the phenyl group because the phenyl group, that's just a benzene ring. It's not part of a chain. Now, I wrote this out really weird, but ethyl group, ET. An ethyl group is right there, kind of like the ethyl group here. And it's on the O terminus, okay? So if I'm looking at the main chain, the pink, all right, I notice this is the only branch. It's a phenyl group. So if I see, hey, the blue is going to be listed first because it's my accessory stuff. So ethyl, 2 phenyl, because I just listed all of my branches. I don't have any other branches. So let's just go ahead and go to the main chain. My main chain is 2 carbons long, 1, 2. FN, noate. Like that. I think in lab, you guys dealt with methyl benzoate, I think. Benzoate. Right? Where, look, hey, you have your accessory group on that O terminus being a separate word. And your main chain right here is benzoate. Now, I think that's a common name. Don't fact check me. Because, yeah. But this is stuff that you've seen before. Yeah. Ethyl 2-phenyl-ethanoate. Let's look over here. Well, now I just flipped it on you guys because look, our main chain, carbonyl carbon, right? The main chain is just a butane. Now if I highlight anything green, I don't see any branches on that main chain. Now let's look on the O terminus. I see a phenyl group. I flipped it on it. I flipped it on you. So now we have a phenyl space butane. I'm going to cross out the E and the suffix O8. Phenylbutanoate. That's it. Now let's throw an alkene in there. So same kind of spiel. Carbonyl carbon, right? Main chain, it's right here. 3 carbons long with an alkene. I don't see any other branches, so there's no other green things I can highlight, no other branches. And I see an accessory tail on that O terminus as another phenyl group. So this would be phenyl. Main chain is going to be propan, 1, 2, 3. And it would be propanoate, but we have an alkene. Prop-2-ene-O8. All right, prop-2-ene-O8. All right, now if I see an alkene, it should ring something in the bell. Ring the bell in your head. Sorry. There should be stereochemistry, E or Z. Well, there is no stereochemistry here because look, H's, right? It's not a stereocenter. Now let's throw something a little weirder at you, okay? So let's start at the beginning. Carbonyl carbon, right here. Main carbon chain, right here. Three carbons is going to be a propane, and I have a branch right here with a bromine. Now let's look at the accessory stuff. Uh-oh, that's an isopropyl group. So would you say isopropyl 2-bromopropanoate? No, that would be a common name because we don't use isopropyl. All right, we're organic chemists. We hate that. We don't want to use. We want to use IUPAC. So let's look. 1, 2, 3. We use our branch of a branch logic. So if we have a propyl group, all right, but the second carbon's attached, it would be propan 2-eel, right? Propan 2-eel, 2-bromo, Let's if I had to count this out. 1, 2, 3. Propanoate. That'd be your name. Propanoate. Okay. So hopefully this makes sense. You guys are welcome to practice on your problem set and the other group's problem set. Now let's get to amides. So let's bring it back. So you might be thinking, well, hey, if I know esters like to identify this accessory group, all right, they like to identify the accessory group and put it at the beginning and then space and then name other stuff. Amides should follow the same logic. Well, the answer is no, it doesn't. You're thinking, why the hell doesn't it do that? I don't fucking know. I'm not IUPAC. Yeah, I'm just here to help you guys. If I'm gonna be honest. So let's go and start at the beginning. So, like the esters, we identify our carbonyl carbon. And whatever chain stems from that, not through the electronegative atoms, so not through the O, not through the N, but the other way, that's our main chain. So the longest chain we can make is a butane. Now let's identify. Well, the butane has 2 methyl branches. Okay. Not only that, but I have an alkyl group on the N. How do I do that? Well, let me think about it. Well, I have 3 methyl groups. I have 2 on the main chain and 1 on the N. Well, if you remember up here, right, a substituted amine, you get not a number, but a letter N, meaning that the methyls on the nitrogen. So I would name this as N. Let's number this out. 1, 2, 3, 4. 2, 2, trimethyl. And when you do a mix of letters and numbers, the letter must come first. It would not be 22N. It would be N22. Weird, nitpicky rule. I know. I'm sorry. Okay. Don't hate on me. So I've identified the accessory chain on the amide and I've identified the branches. Now all this up is the parent. So the parent I know is a butane. So butane, but I dropped the E and the suffix is now amide. Butanamide. That's it. So this is my answer. Now let's look over here. Okay, let's take a look. So thankfully, there are no accessory chains on that amide. Okay, but I do identify, hey, look, I got the carbonyl carbon. If I look at the chain, it would be 1, 2, 3, 4, a butane. All right, not only that, but I have a branch group on that. And you might be thinking, well, hey, isn't alcohol a priority group? Well, compared to an amide, it's nothing. It's just a branch group. So 1, 2, 3, 4, 3 hydroxy, butan, amide. Right? Now let's look over here. Hey, now this one looks a little weird, right? I know. So let's take a look. So let's look at the accessory stuff. Actually, no, not that one first. Let's carbonyl carbon, right? Whatever's stemming off that carbonyl carbon's our chain. We have a 2-carbon chain. That 2-carbon chain does not have any branch groups. So now it's like the accessory stuff. I do see an accessory. It's a phenyl group. Hey. So would I say phenyl space ethanamide? No. We're not naming esters, we're naming amides. There is no space. It would be N. Phenyl. Ethane. Well, ethane, amide, but you drop the E, so it's ethanamide. There you go. Let me draw a different one before we move on to this one. Let's do try naming this one. Well, hey, I see this group right here. Is that an amide? No. They're a carbon away. That's an alpha carbon. There's no carbon difference. This is the amide. Okay. This is the amide, and everything here is a carbon chain. So let me identify that carbonyl carbon. Let's build the parent chain off that. 1, 2, 3, 4, 5. 2, 3, 4, 5. Where, hey, on this second carbon, I have a branch group. And on the electronegative atom, I don't have any accessory groups. So this must be 2 amino pentan amide. There you go. Now let's look over here. Now this looks like a piece of shit, right? I know. Let's identify parent carbon. Okay. Now let's make a carbon chain. 1, 2, 3, 4. There's a butane. 1, 2, 3, 4. We're on that parent chain. I see, hey, look, there's a branch group, a phenyl. Not only that, on the accessory portion, I see 2 phenols. So I have a di-substituted amide, right? So let's take a look. Well, I have 2 phenols and I have another phenyl. Kind of like this example up here. I have 3 methyls. Well, this would thus be N, because remember, both 2 of the 3 phenols are going to be on that nitrogen, and N3 triphenyl butan amide. Isn't that a lovely structure? I know. So let's go ahead and move on to Let me draw some stuff out. So like I said, let's backtrack to aldehydes and ketones. So let's do kind of like how my parent chains are just devolving into lines. You guys can tell what that is, right? I was just joking. So now I'm self-conscious. Let me redraw this. There you go. So if you have an aldehyde, right, that first carbon is going to be the carbonyl carbon 1, 2, 3, 4. Well, what's your functional group? Well, you only have an aldehyde, so you know that's your highest priority. And you have a butane, so it'd be butan. Well, butane, but you drop the E, butan 1-al or butanal, right? Butanal. The first carbon, and the suffix you use is al, like aldehyde. It's in the name. It's not that deep. It's not that deep. Aldehyde, al, ketone, one. So let's flip it on its head. Let's do a butane again, but let's make it a ketone, or an internal carbonyl. So let's look. 1, 2, 3, 4. So butane. Are there any other functional groups? Well, I just see a ketone. That's it. Your highest priority is a ketone. So this would be butane 2-one or butanone. I'm thinking, well, if butanone is also valid, why don't you have to use a number? Well, butanone is weird because it's symmetrical. Because if it was on the third carbon, right, instead, we'll just flip it over. It's still butanone. It's a weird one. He won't throw that at you on the test, but it's just like something to think about. Because on the test, he's going to throw like a bigger structure, obviously. Something like this. Ooh. Something like this. Okay. So, hey, 1, 2, 3, 4. 1, 2, 3, 4. Which way do I go? Well, look, I have 2 functional groups, a ketone and an aldehyde. Which one takes priority? Well, aldehyde, you should know it. And also makes sense because an aldehyde's terminal. So if your aldehyde's terminal, that's probably going to be your first carbon. So I know, hey, we're going to go this way with the red numbers. So now, if I know the suffix for aldehyde is al, and the suffix for ketone is -one, as in ketone, what's the prefix? Because right here, I see a branch. Well, the prefix is going to be this, oxo. 3-oxo butan 1-al. This would be the name. Now, let's kick it up a notch. As you know, this is going to be acetophenone. One of the ones you had to memorize. Well, that's a common name. What's the real name? Well, let's look at the parent chain. I see carbonyl carbon. The chain is just a 2-carbon chain, because remember, the phenyl group's not a part of that. Phenyl is just a branch, right? Phenyl is just a branch. So this would be a 1, 2, 1 phenyl ethan 1-one. There you go. Now let's take a look over here. What if you had 2 of them, right? course there'd be two of them. Why the hell wouldn't there be? Well, I'm sorry. Well, it's just dione. You have oleic acid changing it to dioic acid, or alcohols being to diols. Well, if there's two of them, it's dione. Kind of intuitive. So hey, I see 1, 2, 3, 4, 5. If I counted it the other way, it would be the same. It's symmetrical. So if I see a pentane, this would be pentane. Now it would be pentanone, but remember for the pentane, you keep the E there. You don't drop it because you have a dione. This would be 2, 4, dione. The fact that you have this consonant, you'd keep the E there. Same rules from last semester, right, guys? Hope you guys remember it. Okay. Let's look at something like this. Not this. You might be thinking, how do I do it? Well, you can do it. I gave you the suffix "one" because you obviously you can tell it's a ketone. There's two of them, so it's gonna be a dione. And now let's just use the knowledge we have from first semester. Well, I see a cyclohexane. That's our parent chain. Parent chain is a cyclohexane. And our priority functional groups are gonna be two ketones. So this would be cyclohexane, not cyclohexanone, but you keep the E, cyclohexane, 1, 3, dione. You know, 1, 2, 3, same way. You go the other way around. Yeah. Okay. Let's look at something like this. OH. One more small itty bitty example. Okay. So if I'm looking at this, I see counting this way 1, 2, 3, 4, 5. The other way 1, 2, 3, 4, 5. Which way do I go? Well, which one takes priority? Ketone. Ketone takes priority. So we would go with the blue numbering. So your hydroxy, your OH is now a parent chain, a branch to be 4 hydroxy, pentan, 2 one. Remember, you drop the E, there's only one. Now let's try to get some complicated ones. Now this one is a weird one. I see, look, a carboxylic acid, a ketone, and a phenyl group. What the hell do I do? Well, hey, what's the highest priority? Carboxylic acid. If you know your priority chart, this is the highest priority. So this is a branch. This is a branch. Let's go and start numbering. Well, if I know that for the priority group, the carbonyl carbon is going to be the first carbon. 1, 2, 3. That's where we stop, right? That's where we stop. The ketone, not the ketone, the phenyl group, and it doesn't do anything. This is a branch status group. So if I see a 3 oxo group, a 3 phenyl group, and then a propionic acid, not propionic, propanoic acid. Sorry, that's the propionic is the common name. Well, how do I do it? Well, you just name it alphabetically. No, not numbering wise, but in the IUPAC name, 3 oxo, 3 phenyl, propanoic acid. There you go. Now this one's a little bit of weird. All right, this is the last example I have for you guys. I see, hey, carboxylic acid, branch. Okay, but this is a little weird because instead of a ketone, it's a cyanide, or it's a nitrile group. So now I'm thinking, well, hey, wouldn't this be 1, 2, 3, 4? No, it would not, because remember, the highest priority is going to be your carboxylic acid, right? So if I were to write this out, carbonyl carbon's the first carbon, 1, 2, 3. Nitrile group is now a branch group. So it's going to be 3 cyano, 3 phenyl, propanoic acid. There you go. All right, let me stop my sharing. All right, so hopefully that helps you guys.